Hello everyone, and welcome to On-Demand Geoanalysis and Interactive Dashboarding with FME and ArcGIS Online. I'll be sharing a case study in using the data translation software Feature Manipulation Engine, also known as FME, in ArcGIS Online to automate a geoprocessing routine and bring an interactive ArcGIS Online dashboard to life. My name is James Collins. I'm a senior research analyst with the City of Austin Watershed Protection Department, where I use FME and GIS every day to analyze data and support our missions of protecting lives, property, and the environment from flooding, erosion, and water quality problems. Here's a quick roadmap for my presentation. We'll start by covering the background of this use case and what our business process was lacking. I'll then describe the specific problems we were facing and what our solution needed to address. Then, I'll present the novel solution we've developed for our group using FME and ArcGIS Online. I'll also jump into FME and the new application itself for a demonstration. Finally, I'll briefly zoom out and discuss the strengths of this approach for other applications before taking any questions after the pre-recorded session. So starting with the background of our case. My department, Austin Watershed Protection, is one of the city's municipal utilities. We are responsible for managing stormwater to protect lives, property, and the environment. We accomplish this through a variety of approaches, including constructing and repairing drainage pipes, monitoring water quality in natural creeks, and enforcing code and policy to protect waterways. In the City of Austin, utilities coordinate with each other when pursuing construction projects so that we can, quote-unquote, dig once, essentially constructing or repairing multiple infrastructure systems while the right-of-way is dug up. This saves time and money and minimizes disruption to residents and businesses. In practice, this involves spatial analysis between two categories of features. One category feature is the footprint of right-of-way permits. These polygon features represent where upcoming public and private right-of-way work is planned to occur. The other category of feature is lines, representing drainage pipe assets. These include a rich set of attributes that describe the condition and criticality of each stretch of pipe. The analysis performed by GIS staff involves spatial relating, permit boundaries, and asset features, then calculating summary statistics of asset features falling in each permit area. The information is then used by utility coordination staff to determine where old or undersized pipes exist in upcoming permit areas, and therefore, where our department should engage with other departments to coordinate work. This analysis has historically been performed by GIS staff, a repetitive task that consumes staff time and limits the volume of construction permits that can be assessed. Let's walk through a process diagram of sorts for this analysis task. Coordination staff request that GIS staff analyze one or a set of permits at a time. GIS staff then access spatial data representing permits, assets, and previous review performed by coordination staff. Next, GIS staff perform a spatial intersection analysis to determine which permits overlap old, damaged, or low-performing drainage pipes. GIS staff then summarize this spatial analysis in a written report, which informs coordination staff on which permits are a priority for utility coordination. As our diagram suggests, this approach requires a considerable amount of GIS staff time to access data, perform analysis, and create reports. The problems with this existing approach were that repetitive analyses consumed staff time, and the time required to analyze each permit meant that only a limited volume of permits could be reviewed. In practice, this meant that coordination staff only reviewed specific types of permits, even though they would have preferred to not have that limit. Finally, the outcome of this process was a static presentation of the data. If coordination staff had follow-up questions or wanted greater detail, that meant going back and requesting more work from GIS staff. To address these problems, we developed a new application and data processing workflow using Feature Manipulation Engine and ArcGIS Online dashboards. We used FME to automate the spatial analysis and report generation components of the workflow. And instead of creating a static report like a PDF, FME populates an ArcGIS Online dashboard with annotated permit features to present the information interactively. So to diagram this new approach, coordination staff now begin by executing the FME process via a simple online form. The input datasets are accessed and analyzed automatically by the FME process, which then populates the ArcGIS Online dashboard. This dashboard is then used by coordination staff to inform decision-making. GIS staff are now largely removed from the day-to-day process of analyzing and accessing this information, and are largely taken to a maintenance role over the whole process. This means that the main process flow involves coordination staff, FME, and ArcGIS Online, and the coordination staff only need to engage with GIS staff for maintenance requests. I'll now jump into a brief demonstration of this new process. Let's start by looking at the interactive ArcGIS Online dashboard that was created for this use case. This dashboard can be accessed by coordination staff via a web browser. It's roughly arranged from left to right. Staff began by using the filters in the left-hand pane to filter down the list of available permits for review. The agenda date filter corresponds to the meeting dates at which coordination staff discuss these permits. So let's start by selecting agenda date January 1st of 2022, which I've entered as an example. After selecting an agenda date, the permit list will be populated with permits and permit areas related to that agenda date. This list includes some identifying information, such as this ID and a name, as well as some coordination-specific information generated by FME, including whether the area already appears on the review list of features that have been reviewed, as well as the maximum pipe risk score of pipes intersecting the permit area. So after selecting a specific permit, we now get more detail about that area. This permit details pane is populated with information relating to that permit, including more identifying information, the date that it was last reviewed, streets adjacent to storm pipes in the permit area, maximum risk scores for different risk categories for pipes intersecting that area, as well as summary statistics for those risk scores, including the minimum, median, and maximum for scores of pipes intersecting that area. Staff can also use the map to see where the permit area is, as well as the pipe features intersecting that area. Staff can also use the layer list to symbolize the pipe features, as well as other features in different ways, along different risk or criticality scores. The application used to initiate the FME workspace to update this dashboard is integrated with the dashboard itself. So when coordination staff are ready to add additional permits for new agenda dates, they can click on this menu and then follow this Add Data link. So this form is what's called a server application created by FME Server. FME Server is a way to host workspaces or data workflows on a separate machine that can be accessed via URL or over the web. And this allows anyone to submit jobs to these FME workspaces for processing. So this FME Server application is essentially just a UI for the FME workspace or workflow that populates our review dashboard. It's very simple and just has some descriptive text, a link going back to the dashboard, and at the bottom here, it asks for 3 parameters. The first is a comma-separated list of row IDs or permit IDs to include in the report. Then it asks for an email address to send a notification to when the job is complete. And finally, it asks for that agenda date corresponding to the set of permits that will be discussed at that meeting. So coordination staff simply have to populate these 3 parameters, click this OK button, and that begins the automated data processing workflow in the background. Finally, let's take a look under the hood, so to speak, at the FME workspace that's powering this automated data translation. So this is FME Desktop, where you can author what are called FME workspaces, which are essentially workflows for processing and transforming data. Each of these modules, which are called transformers, are essentially small snippets of code that read in, transform, modify, and write out data from the workspace. Over here, I'll point out the 3 parameters that we saw in the server app web form. That was the comma-separated list of permit IDs, the email addresses to notify, and the meeting date. So that's where we set the parameters for the workspace, as in this desktop application. So this is a pretty complicated workspace, and I'll just walk through it from a high level at each of the major steps. So we begin by reading in the relevant data, which in this case would be the right-of-way permits for the work that we're interested in considering for coordination. So we begin by reading in permit features or lines showing where the work will be done from our enterprise GIS using that permit ID parameter. We then read in some more data of interest, including that previous review list that I mentioned in the dashboard, as well as all of the asset layers that we're going to use for the spatial intersection analysis. So further down, this is sort of the meat and potatoes of the analysis, where we're using a transformer called a spatial relator to relate the permit feature with all of the asset management features. And when we do this, we make a copy of all the attributes on the asset management features, such as those risk and condition and criticality scores. So we make a copy of all of those attributes and append that as an array onto the permit feature. We're then able to analyze that array of attributes to create summary statistics, such as the minimum, the median, and maximum of those different asset condition scores. We do some additional spatial analysis with other areas of interest, like where there's repeated flooding, and then we're ready to write this enriched permit data set out to our ArcGIS Online feature service to be consumed by the dashboard. So to do that, I actually begin by reading in the existing ArcGIS Online features. And that way, I can do a comparison down here of where there's existing permits for a specific agenda date, which means I need to overwrite what's already there. So I can do some pretty, sophisticated logic on these features and determine which ones need to be inserted as new rows and which ones need to be deleted and overwritten. And that's where all this occurs here. So FME handles all of the logic, the analysis, and even the writing of these features to ArcGIS Online and keeping our feature service up to date. And then finally, we send that email notification to the email addresses that were supplied as a user parameter. So to recap, the previous approach to utility coordination had the problem of tying up staff time, only being able to get a limited volume of permits reviewed, and presenting information in a single static view. Our solution addresses these problems by automating the analysis of spatial data so as to free up staff time, which results in a greater capacity to review permits. We also now present the data interactively to make discussions and decision-making smoother by allowing for further investigation and follow-up questions to be asked of the data in the dashboard. To wrap up, I want to move from our specific use case to the abstract case by pointing out general conditions for which this automated processing and ArcGIS Online dashboard approach may be suitable. You may want to consider such an approach if your process involves a consistent set of analysis steps applied to a consistent set of input data sets. Essentially, if the process is largely rinse and repeat, or performing the same steps on the same data. Importantly, you'll want to identify parameters in the analysis that need to be set by the user. In our case, the key parameter set by coordination staff was the set of permit IDs they wanted to analyze. This approach works well for deriving descriptive statistics about input data sets to display in the dashboard. In our case, these included minima and maxima of pipe condition scores in each permit area. Finally, this can be a useful approach when the user or customer groups involved do not have GIS capacity and need to work with more intuitive or preset interfaces. Other potential applications for this method may be in site engineering, architecture, municipal programs, or other situations where spatial analysis is repeated in a particular area over time and presented to a user group. That concludes my presentation. I hope this was a useful demonstration in how FME can be an analysis engine for ArcGIS Online products to save time, deliver information faster, and enhance data presentation. Please feel free to contact me for more information or resources from the process shown here. I'd also love to connect via email or LinkedIn to meet y'all and learn more about your work. Thank you.